So under compaction process, the previous video we discussed with some of the compaction process, that is cold isostatic compaction process, like compaction process. So further we will see the dynamic powder compaction. It is a single compaction centering operation brought about by the impact of high-speed punch on the powder. This produces a discrete shock wave in the powder under optimized conditions, results in metallurgical bonding and sometimes fusion of the particle surface. The work of the compaction produced by the inner particle shear is transferred on the surface of the powder in such a short time that there is no possibility of heat to be conducted away from the surface, and thus localized melting or welding occurs. Powder roll compaction. Powder roll compaction is also roll compacting. It is important process to produce metal strips. In powder rolling, metal powder is fed from a hopper into a gap of rolling mill and emerges from the gap as a continuous compacted green strips. Rolls of the mill may be arranged vertically or horizontally. The latter type of arrangement is more common with either saturated feed or starved feed. So sintering is another process by which an assembly of particles compacted under pressure or simply confined in a container chemically bond themselves into a coherent body under the influence of an elevated temperature. The temperature is usually below the melting point of the major constituent. The driving force of solid state sintering is the excess surface energy. The various stages of sintering can be grouped in the following sequence: initial bonding among particles, neck growth, pore channel closure, pore rounding, densification of pore shrinkage, pore coarsening. Liquid phase sintering, it happens with the cycle of materials used for enhanced densification. There are two variations of the process: normal liquid phase sintering. The formation of liquid phase is associated with one or more components contained in the original green compact. Another one is activated sintering. Sintering is lower, it is mostly achieved by chemical addition of powder. For certain metals, particularly refractory metals, the addition of dopant causes the densification kinetics to increase as much as 100 times compared with the undoped compacts. The best activators are palladium and nickel. Nickel is often added as a solution of its salt, which is reduced to metal and forms a layer, several monoatomic layers thick on the surface of tungsten powder particles. Low sintering is applied to manufacture of highly porous parts like filters. Basically, metal powder is poured or vibrated into a mold, which is then heated to the sintering temperature in an appropriate atmosphere. Shrinking usually takes place during sintering. Only shape where this can occur without mold constraint causing crack can be used. The characteristics of sintering are easily machined or formed into the required shape, withstand sintering temperature without appreciable deformation. It should not weld to the powder during sintering. For most applications like machined or welded metal molds are used. So powder metallurgy application. Powder metallurgy application are to produce a porous product. Further, babbitt bearing for automobiles, to produce oil pump gear for automobiles. Used for production of cutting tools, wide drawing dies and deep drawing dies. To produce refractive metal composites like tungsten, molybdenum, tantalum, for manufacturing tungsten wires for filaments in the lamp industry. Diamond impregnated tools to produce electrical contract material, circuit breakers, relays, resistance welding electrode, parts of cars, aircrafts, gas turbine, electric clocks, parts of vacuum cleaner, refrigerator parts of gun, sewing machine. These are all the powder metallurgy application. So course outcome of the fourth module is correlate between material properties with composite design and identify various kinds of defects. So the course learning objectives is explain the powder metallurgy process types and surface modification. So by all the videos, what all it is observed, all the course learning objectives have been achieved, and for the fourth module, the course learning objective is also achieved. So even the PSO1 as it is applied, you are going to, when we go with design, the materials knowledge is very much to make the decisions and to go into the process. If you want to design and implement new ideas, the knowledge of materials is very much important. Otherwise, you cannot design a good product. So first basic thing is you need the material knowledge to do design of any component.